Hey everyone, my name is Arnav and today we'll be talking about threat detection in Kubernetes using HoneyCluster. HoneyCluster is a tool which I developed, tool architecture actually. There's a bit of difference in that. Just want to talk a little bit about why this over here. So in my observation, most of the Kubernetes security talks are about threat prevention. They talk about how do you harden the cluster, how do you make the cluster secure. Whereas there's very little or to no talk about what to do when your hardening fails and there's an attack inside a cluster. In my observation, there has been a lot of investment, especially open source investment, when it comes to detecting attacks in Kubernetes. So this talk is about that and an approach which I thought would be nice to share. So a little bit about me. So I currently work in Kaseya as part of security operations. I have a master's degree from Trinity College. I have around 3 years of experience in security and DevOps. So my first year of my career was as a DevOps engineer, and I played a lot with Kubernetes, like scaling, securing, deploying, etc. That's where I started to like Kubernetes. And yeah, that is me. It's not a flattering pic, but I like the signboard. So yeah, coming to the agenda for today. So today we'll be covering a bit about the scenario, what's going on in Kubernetes security and how the approach has usually been. Then we'll talk about HoneyCluster, the tool which I developed and how it was built. A demo, obviously, because there's no point in just showing the tool's capabilities and not demonstrating it. And then we'll talk about limitations for the tool because nothing is perfect. So yeah, a little bit about Kubernetes. So yeah, before this, just want to understand how many of you have worked with Kubernetes? Show of hands. Okay, so we have a lot of traumatized individuals. So for people who haven't worked on it, Kubernetes is kind of like a software, I guess. So where you deploy applications and then so it helps in scaling and auto scaling and like it has self-healing as well. So the applications are kind of called pods over there. And yeah, so the pods are separated with something called as namespace. It's like a logical separation. So, for example, you have a finance department, you have an IT department, you would have a namespace called finance, where you deploy the finance applications, a namespace called IT, which would have IT applications, and all the applications over there. One more thing. Kubernetes follows something called as a master-slave architecture. So there's a master node, which kind of controls the entire cluster, and the slave nodes usually have the application deployed. So as you can imagine, the master node is pretty powerful and it has a lot of components. One component I would like to talk about is the API server. So the API server is like as the name suggests, it has a lot of endpoints. The workloads and the admins interact with the endpoints a lot to deploy and manage the applications. So as you would imagine, if an attacker gets their hands on the API server, that is usually a target in Kubernetes environments. They can wreak havoc. Bad news is that Kubernetes does not have a good default security posture. So all the workloads and admins, they usually interact with the API server through tokens. Now those tokens are usually not secure by default. You need to spend some time securing it. At the same time, there's something called RBAC, so role-based access control. That is also very permissive by default. And one more thing is that Kubernetes has something called as audit logs, so which will have a record of each and every API endpoint it hit. However, it is usually disabled because of costing purposes. It is a bit complex to manage as well. So that was about Kubernetes. So a typical attack. So I just want to talk about a typical attack in Kubernetes. So usually an attacker would find an application and compromise it, get a shell on it. And then they would try to see what permissions the applications have, escalate the privileges, and then the end goal is usually to get to the API server where they can control the cluster sort of thing. But even if not that, they try to extract secrets, whatever the pod has access to. And so it's a lot of token-based and continuous reconnaissance, stuff like that. So that is usually how an attack goes. So it usually starts off with an application and then you get access to service account tokens and go on. Historical Kubernetes attacks, there are a lot of them, but I like these two over here. One of them being a Tesla. This is a very famous one. So Tesla was breached because Kubernetes has something called as a Kubernetes dashboard. And that dashboard, it used to be enabled by default. Now it's not enabled. The dashboard, you would have access to all of the cluster components, and if an attacker got the hands on it, they could read secrets, and that's exactly what it did. They found some AWS credentials, and then they just took it off and tried to deploy crypto miners, and they got to know it in the form of a cloud bill. The other one is a campaign where if you remember the API server, right? So there is anonymous access to it. So you don't even need token to hit to the endpoints. So that is pretty bad, as you can imagine. An attacker can schedule pods. An attacker can read all secrets in a cluster environment. And that is exactly what happened over there in the CryptoZine campaign. No idea why it was anonymous. Seems pretty weird to me, but yeah. So in summary, currently, now people are aware that Kubernetes can be attacked. So they spend a lot of time on making sure the permissions are fine, network policies are fine. So network policies are the policies where you control the traffic in the Kubernetes environment. You have something called pod security, so you can ensure that the pods, nobody can escalate through your pods, escalate the privileges. But again, there is, at least I feel personally, there is less focus on detection. And because one of the key reasons is that audit logs are disabled by default. I worked in the company for 1 year and we didn't have audit logs because of costing purposes. And that is a bit problematic. And yeah, like I mentioned in the beaches before, most people don't even know what's going on in the environment and they come to know weeks later through a cloud bill. So that is the problem in hand. And the way I thought about it is by creating an open source tool called HoneyCluster. Actually, the name is KubeDecoy. I changed the name a few weeks ago, but by the time the conference was there, the name was HoneyCluster, so I kept it that way. So it's kind of an open source tool which I built using other open source tools. It's kind of like stitched together other tools to build it, because I don't believe in reinventing the wheel. I think there are a lot of really good open source tools which already do the work for you. And why not leverage the capabilities and keep them all together? So one of the important things is that, so the way it does is that it kind of simulates another cluster, and you are intending an attacker to get a shell in the cluster, but because it's a honeypot, the attacker thinks they are exploiting your cluster. However, they are actually inside a honeypot, and that will not cause any damage, and you can actually catch the attackers before the real damage. So you can capture the IOCs, like IP addresses, JSD hashes, stuff like that, and you can just block it preemptively before they get to production. Now, let's talk about the tools which make it. So we have around 4 tools, which are the core components, which I have sort of stitched together. The first one is vCluster. So vCluster is an open source tool which gives you a virtual Kubernetes cluster. So it gives you all the capabilities of a cluster, except it's a virtual cluster. So it is contained inside another namespace. So it gives the impression that it's a real cluster, but it's not. It's a vCluster. It's a very lightweight cluster, important part. So yeah, like I mentioned, it gives the attacker a feel of that it's in a real cluster, but they're not. Falco is a very popular open source tool. Has anybody used Falco by any chance before? Okay, so Falco is an open source tool where it detects system calls. So if an attacker gets a shell on the pod, if an attacker runs a curl command, those kind of things Falco is able to detect. So that's the use of Falco for this project. So it's going to detect all the behaviors of what an attacker does inside a shell. Nginx, I'm sure Nginx everybody's familiar with. It is a proxy, and I'm using it to capture all the interactions with the Kube API server. Why am I using Nginx? It's because vCluster does not have audit logs in the open source version. It has audit logs in the pro version, but I want to keep it open source friendly. That's why I use Nginx I use Nginx to proxy all the API interactions. And Falco Sidekick, that's the final piece of the puzzle. So that kind of helps me in stitching all the alerts and sending it to a dashboard. So the good thing is that Falco Sidekick has its own dashboard where I can consume all the alerts and see the data. But you can also use Slack. Let's say you got an attack on your cluster. You want the alerts to come on Slack. You can do it with Falco Sidekick as well. So that is the use of Sidekick. So it helps in centralizing all the data. This is the architecture of kube decoy. So this is like the attacker, and the attacker gets there's a pod. I mean, it's usually you want the attacker to discover the pod because it's supposed to be a honeypot. Attacker gets a remote execution. When the attacker thinks it's in a Kubernetes cluster, you have to make sure that the attacker thinks that way, and I'll show how I think it can work. And the attacker thinks, okay, I've struck gold, I've got the API server. The attacker runs the queries on the API server, except the API server is over here. The data comes over here, and everything the attacker does is reported to the UI. So the moment you see any logs on the UI, you know that the attacker is interacting with your HoneyCluster. So yeah, I can talk a lot about kube decoy, but the point is that there has to be a scenario which makes sense. So this is a story which I have developed, and I will also show you why it's heuristic. So it's maybe 2 a.m., let's say, and attackers, they don't really target as such. They try to scan the internet for any resources, and the attacker comes across your application. It's an application, and they find a form. They think, okay, there's a form over there. That means there is user input, and if the user input, they can try to probably get some a shell over there. And luckily for the attacker, it has something called as a server-side template injection, a very popular vulnerability, which can result in remote execution. And then the attacker exploits it. It's very easy to exploit. And then the attacker gets in the shell, but the attacker thinks it's just a random application. So usually attackers, they try to run some recon scripts inside the shell they get, and then they realize they run config files, and they realize that it's a Kubernetes cluster. One of the key ways of realizing it's a cluster is that if you run etchost, the cat etchost command, it will usually have an entry for the kube API service. By default, that's enabled. You can disable it, of course, but in most clusters, by default, it's enabled. And even if you run the env command, you can see the environment variables and see that it's inside a cluster. So now the attacker thinks that, okay, let me just try my luck. Why maybe the kube API server is misconfigured. Luckily for the attacker, it is misconfigured. But luckily for us, it's deliberate. It's supposed to be misconfigured by us. And so the attacker is happy. He's able to run this command. So if you run this endpoint over here, /pods, you can list all the pods over here. Similarly, if you run /secrets, it's going to list all the secrets over there. And the attacker thinks they have got bingo. They have got the keys to the kingdom. However, each and every step, including the RC being exploited, including the shell being spawned, including the curl commands being run, including what endpoints the attacker is doing, everything is logged and sent to kube decoy, the Falco sidekick, but yeah, kube decoy. So this was a story. Let's see it in action maybe, because maybe that will help paint a better picture for this. So I got a recording of the scenario over here because I don't trust my computer. Oh yeah, I think. Oh yeah, now it's good. So I got a shell over there, and I'm the attacker. So I run the etchost command like I suggest. I see this entry. So I know for a fact that that's an entry in most Kubernetes environments. So I try my luck. 8443 is the default port in Minikube. So maybe the attacker thought that, and the attacker can see a lot of endpoints for the kube API server. And the attacker thought, okay, let's try for secrets. And yeah. Oh, so I have secrets over there. And it's base64, that's how Kubernetes stores secrets. So if you decode it, you'll get your secrets. However, this is the Falco sidekick dashboard over here. I can see each and every step over here. I just made this custom alert for myself. This is the Falco alert. The shell was spawned. That's the default Falco alert. And yeah, so this is the dashboard which Falco gives. However, you can build your own dashboard. That's the beauty of it. And yeah, so each and every step of the attacker was logged. And now you have an IOC. You have an IP address to block. And you can just go ahead and block it. So this was the scenario. And now the scenario is a good story. I think it's a good story at least. But if you see, there's something called as the threat matrix, which Microsoft released. And each and every step of the scenario maps into it. That's how I get my validation that the scenario is not so improbable. Because initial access, we got the application vulnerability over here. Execution, you execute it into a container, or you can do RC over there. And how about maybe credential access? the attacker listing the Kubernetes secrets, and in discovery, the attacker is trying to access the API server and trying to get more data. So I kind of wanted to map the kube architecture and scenario to the threat matrix, which gives an idea that, okay, maybe the scenario is not that improbable. Yeah, coming to the features for kube, I think the best feature for this one is that it is lightweight. It doesn't take up much of the resources. I know for a fact that since I was in DevOps, that each and everything we had to monitor and find out how much resources does it take up, because costing is a big factor. However, this is just, you get one namespace since it's a vCluster. So it's pretty easy to deploy, and you can add your own custom alerting. So I did an alerting for it's too late to go that, but I did an alerting for any interaction with the HoneyCluster to show up as a Kube API interaction going. If you remember the demo, you can put whatever we want for that. Maybe you want to be alerted when the attacker runs a /secrets. You can do that. So stuff like that. And yeah, I think a good thing is that you also get isolation. It's a vCluster, so attacker, and you make sure that you put all your heart to isolate the vCluster. You can do it. It's not that difficult. You just have to make sure it has 0 permissions. You put all your policies to make sure that the traffic doesn't go out of there. You can do it with Kubernetes. So that gives you confidence that it is completely isolated. And that can basically help you, give you the confidence that an attacker would be like, even if the attacker does find the HoneyCluster, they cannot escape out of it. So there are limitations, of course. And I think one of the biggest limitations which I faced is that vCluster open source is a bit limited. The Pro one has a lot more features, but I cannot leverage it. I don't want to deep dive too much into it, but due to some issues the initial access pod had to be deployed outside the vCluster, and then the attacker kind of interacts with the vCluster. It's a bit risky, but I think it's worth taking the risk. But however, that I still feel that comes under a limitation that you don't get complete isolation in that case. I have not really researched it for cloud Kubernetes environments, but in my view, it shouldn't be that different because I'm still using the same components. And the project, which I will show in a bit, I feel the code can be a bit structured, but yeah, that I feel is a limitation. So I would love if there were more contributions for this tool, which is the main reason why I wanted to showcase this in B-Sides. And so the part which I really would want the community is to provide detection rules, because every company would operate differently, and that would give me more ideas about detection and how each organization looks at detection. And right now I'm using the Falco Sidekick dashboard as my default dashboard. However, it would be great if I get ideas for other integrations. It would be cool to integrate them as well. And feel free to scan the QR to get the code. I totally used them. And to sum it up, I think deception is a good way to detect attacks. Hardening is great, of course, but deception is a way where you know for a fact that the IP is attacking your infra, and it's good. It would be nice to detect them before the IP is attacking the production. I feel kube gives a good amount of exposure to that. And that is it. Any questions? Sure.
More on the when it returns the list of pods, if an attacker is specifically looking for a customer, you could actually return exactly their customer.
Yes.
Looks like their customer.
Yes, correct.
Right down to the image level.
Sorry?
Right down to the image level.
Yes. That's
and then the attacker really thinks they're on the real customer.
Yes. Yeah, correct. So you can put anything you want. So even the demo, right? Sorry, over here. So I've put payment API DB. Those are random names I've put. So the attacker will try to attack them. The attacker will think, if it's a DB backup, the attacker is going to try and to see if it can get any secrets out of it. And you can give it the attacker whatever he wants.
Whatever they believe they should see.
Yeah, whatever they believe they should see. So that's the thing, right? So attackers, they are skilled, of course, but I would say 95% of them just are script kiddies. They just run whatever they want to run, and they see output, they're excited, but we control the output, so that's one way. You can also add additional detections. So this AWS access key, right? To be sure that somebody is really attacking your cluster, you can put in, give a honey token. So if the AWS access key has any endpoints, any logs, that means an attacker is actively trying to exploit the environment. You can add more, ingrain more into it. So yeah, the idea is limitless in this case.
So you're just mocking the API server, is it? You're not actually running a vCluster.
No, we're running a vCluster. So vCluster is the one.
These are mock responses, is it?
No, yeah. So coming to that, these are all real responses. And I'm not doing mock responses because there are a lot of
There's a lot of endpoints.
Yeah. So, and that's the thing. So vCluster gives me all the benefits of a real cluster. So
how do you mock all these pods?
You can just deploy a pod in the vCluster.
Oh, so you are deploying.
Yeah. But yeah, you do take care to not have those pods, the basic taking care of it. But yeah, these are all real responses. I cannot mock, I think there are 100 endpoints, so I don't want to mock all the endpoints. And there's a thing, right? So if an attacker tries to list all the API endpoints, the attacker sees only 5 endpoints. The attacker might think, it's probably a fake one. So if it's a real API server, just might as well just use it.
Return 403 for some of them.
Yeah. I've enabled anonymous access for that. So that's why it's showing up huge. But you can also control whatever endpoints you want the attacker to see. You get like complete control for whatever you want. So yeah. Coming to this now, coming to your thing. This is the repository over here. Okay. Just browse through it. I've given steps on how to deploy everything. So how to deploy Falco and stuff like that. Before coming here, I tested it 3 times by running all the instructions. They work fine, at least for me. So maybe try it out. I've given an explanation as to why this DNS, like I had to deploy it outside the vCluster. You can go through it if you want to. And coming to the vCluster. So yeah, this is where I actually control the vCluster things. So over here, yeah, so I put the API server and anonymous out true, which is why it's giving all the endpoints over there. You can control, you can do whatever you want over here. And yeah. So yeah, this is the folder where you can deploy. Okay, this is initial access. This is a application which I made. This is vulnerable workload. So over here you can put whatever workloads you want to mock this one, and the attacker will think that they have access to real workloads. And this is the config for Nginx. So if I come to Nginx conf, yeah. So over here right now, I have put a rule that anything before secret, any endpoint, I get this alert over here in Falco Cycle. So you can do whatever you want over here. So it's very customizable, which is what I really wanted to showcase to the community, that you can do whatever you want. Yes. Any more questions?
Would you deploy using a dedicated namespace for your production cluster?
Yes, correct. And you would have taken caution to isolate it further, harden it, yeah. But then that's the thing, that you're hardening one namespace over there. It's a lot easier to harden one namespace than, let's say, 50 namespaces.
Yeah. So, have you got any real attack?
No, I haven't tested out in real because that would require me to provision a cloud infra and do it. It would incur cost. It would take weeks off. I would have deployed weeks for week continuously. So that's why I didn't do it. That's why I focused more on mapping it to the threat matrix rather than deploying it. Yeah. Any more questions? Okay. Thank you.